Well, it's a piece of information that should not go out over YouTube. So, yeah, so a census, fortunately I didn't get too far into it. Yeah, you're collecting data from every member of the population. So I doubt it picked you up too, but there's a
I
chance.
doubt. I mean,
But it definitely got me. It definitely did. But it rattles off the brain. It's like, how do you know this? I'm like, well, I received many a ticket in my youth, and also some not in my
I
youth.
used to always lose my license.
Yeah,
Remember the stupid number?
yeah.
What's the number?
I've gone down that road before. Um, and then also you needed to back in the day if you had to give write a check back when checks were a thing, they wanted your license number. So you didn't have your license with you. What did you do? You just wrote the license number on the check when you gave it to them because that's all they were doing anyway. So a lot of things. Oh, by the way, a check is a piece of paper that one would use to indicate a dollar amount that would be withdrawn from a bank account to transfer to another person. So it's kind of like not a wire transfer. It's not like like Venmo. Basically, Venmo on paper. For those of you who don't know. All right. In high school, I actually have to explain things like that, like a check, a phone book, what that was. I was like, yeah, it's used for bashing people over the no. Oh yeah, the crank. I had the misfortune of what the crank, the like the teeth on the crank on the inner workings of it got stripped, and so I had to take a lock wrench and then use that until I could get down to Hunts Point. And then, you know, because they have everything down there, just not always legally. But so a sample would be the relatively small grouping of individuals used to draw conclusions about the whole population. So that's kind of where we would be living. The idea would be if we can draw conclusions about a small sample and then transmit or project those conclusions to the larger population, then maybe those conclusions would be meaningful. You know, so if our sample is representative of the population, then we can look at it as a subset of the population, and whatever conclusions apply to the sample could apply to the population. It's just a question of in what way, and that's what we'll flesh out as we move forward. That's pretty interesting stuff. You know, like you could think of I don't know, practical, or not even practical, but just an analogy to that. It's like, you know, you talk about like family history, right? You know, so what do they ask you? You go to the doctor, you say that you have a pain in your chest. The first thing they ask you is any history of heart disease in your family. Well, why do they ask you that? Because you are a subset of a population, the population being your family, right? So they're kind of going the other way with it, basically saying that there's information about the population that might apply to you as an individual. But you could also look at it the other way, where they would say, you know, any conclusion they draw about you individually could work backwards. You know, so I go to the hospital or I go to the doctor and they diagnose me with something. That something could have, you know, a heredity component to it. So then I could go back and I say, hey, mom, brother, sister, you might want to have yourself checked out because this is something that could apply to you too. Why do you know that? Because I am a representative sample of my population, right? And so knowing that, knowing something about me can help know something about everyone in that population, right? So that I think is probably a pretty good analogy, hopefully. Individuals, member of a population, not necessarily a person. So if I define a population as, you know, all the cards in a deck, then an individual will be a single deck, a single card in the deck. All right. So again, population, individual sounds an awful lot like people, but it's not always. Numerical measurements. You have parameters and statistics. Rightly so, bless you. Rightly so, we had been working with statistics because that is the name of the course. Statistics describe samples. They're numbers used to describe samples. So when we talked about a sample mean, sample standard deviation, sample percentage, those are all statistics because they're related to the sample. Once I go out to a population, I'm dealing with parameters, right? So we learn about statistics so that we can apply it to the population and therefore learn something about the parameters, all right? Quantitative, qualitative. We've done a lot with quantitative data represented numerically, counts, measurements. All right, so anything that you can find the mean standard deviation of, that's probably going to be quantitative, unless you're finding the mean and standard deviation of something you shouldn't be finding the mean and standard deviation of. I've had it before where, and it happens with the project, where people will say, okay, I'm going to find the proportion of M&Ms that are red. I don't. I mean, the M&M study it's fine, but it's not as interesting as some of the other studies that could be out there. Um, more conclusive. But anyway, that person said, I'm going to let red equal 0, blue equal 1, brown equal 2, and so on. Went down the line. And then found the average and said the average is the mean of the sample is like 3.25 or whatever it was. And I looked at it and I was like, all right, cool. What the hell does that mean? The student had no idea because it didn't make sense to take the mean in that situation, because those numbers were just labels for colors. Like there was no numerical component associated with the colors. Like red is not equal to 0. Now, if 0 represented the amount of blue dye or something in there, then okay, now you have a case for using the mean. But if it's just a label, it has no meaning to me or anyone. So why would I find the mean or the standard deviation? Like the average is 3.25. So the average is like yellow and a quarter brown. Like I don't know, mixed together somehow. That doesn't make any sense. Now in that case, the mode would make perfect sense, because the mode would tell me the most common number that comes up. So if I saw that the number 3 happened more than every other number, that's great. That means that whatever color that is associated with the number 3 is happening more than all the other colors. That's meaningful information. So mean and standard deviation, median even, not meaningful, but the mode in that situation means a great deal. All right. So all of that is to tell us that when we're dealing with quantitative data, we want to be looking to the mean and median. When we're looking at qualitative data, we want to be looking at the mode. All right. Now, the mode could also be useful to evaluate quantitative data. It's just pretty rare. I mean, honestly, I can't think of a situation where the mode would be the sole metric used in quantitative data. It would be more of a supporting metric. So you'd use the mean and the median, and then while you're at it, you might as well use the mode and draw some conclusions with that. But in the case of qualitative data, that's where the mode comes into play. So breaking up into categories, you're talking like gender, age groups, course of math that you're taking. There are some, I'll call them hybrid ideas, where you might have something that is categorical and also quantitative at the same time. So I might look at this, like the times that we listed here. The times, I could look at them, they're definitely quantitative because they're numerical, but I can also use them to break up into categories. You know, I could say the folks who didn't take so long to get home, although they thought they were taking a long time to go home and they thought they had a really interesting story, but definitely did not have as interesting a story as some other people. So you could break them up into different groups, making them into categorical data, whereas you could still also look at the quantitative side of things. All right, so there's a lot of moving parts there, but usually it's pretty easy to see what's qualitative. Sometimes quantitative is a little different. When you're looking at quantitative, and this is the kind of the payoff slash price you have to pay, I guess, for quantitative data. There's more work to do. Right? You have discrete data and you have continuous data. Discrete data is your finite data, so anything that's countable. So I'll highlight that. Basically, if you can't count it, you can't determine its value just by counting it, then it's not discrete. Meaning, if you need some kind of measuring device, it's not discrete. I can determine how many chairs there are in this room just by counting. I don't need a ruler for that. I don't need a stopwatch. I don't need a smartphone. Nothing. I just need one of these. Let the record show that I'm holding my right index finger up in the air. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Right? That makes it discrete. Measuring device, that makes it continuous. It's kind of annoying, though, because those two words don't really lend themselves to their definition. We like words that kind of tell us what they mean just by the word itself. So, unfortunately, not the case there. The examples, first few things that came to mind: number of wins in a baseball season, number of students in a class, count of eggs in a basket, things that you count up. That doesn't mean that it'll always be easy to count it up. It just means that it can be counted. Like, for example, discrete information, the population of human beings. I technically could, if I wanted to, attempt to count up the number of humans on the planet. There's a lot of them. So it would be too hard to do it, but I don't need anything more than an index finger to do that. All right. If I needed the heights of the humans, I can't just count. I can't say you're this many tall. All right, I need a measuring device. And also the reason, well, I don't know if this is the reason why it's called continuous, but it's sort of, we'll call it a justification. The level of accuracy in your measurement is dependent on the accuracy of the measuring device. So, I mean, we've all stepped on a scale at one point or another. Like, sometimes multiple scales on the same day. When I'm going to the doctor's office, because I always have it in my head that the doctor's scale is the good one. That's the accurate one. My piece of crap one from Bed Bath & Beyond, that's not good. But if I could just figure out the relationship between that and the good one, then I can make my crappy one work. So I get on my scale, see what it says, then go to the doctor's office, see that it's off by 3 pounds, so I know I can just take the difference between the two. All right. Better scale, not quite as good of a scale. All right. Continuous data, because depending on what kind of scale I use, I'm going to get more or less accurate information. All right. Same idea with counting time. All right. I can count time by 1 Mississippi, 2 Mississippi, 3 Mississippi, or I can follow the second hand on that clock, or I can get a stopwatch out, or I could get one of those fancy scientific clocks that have like what's the one below a second, nanosecond, microsecond? Well, it's like the tenths of a second, and then there's the one below that. Yeah, it's one of them. It's something even more precise than it going by tenths of a second. Not overly useful in my line of work, but that it would impact the accuracy of the data. All right, same thing with thermometers and things like that. All right. But generally, sometimes all we need is a ballpark figure. Like if I need the length of a foot, for example, I don't need it down to the nearest micrometer. I just need to know whether my foot will fit in a shoe. So I need a general sense of the length of my foot, a corresponding shoe size, which would be discrete, by the way, because that's not something you would measure. It's a size 12 or 11 and a half or 11 or whatever. Those are based off of measurements, but that's discrete data. All right, so I just need to know which category I fit into and then go from there. All right, so accuracy is the name of the game. we classify our data. So if we have either qualitative or quantitative data, it can be classified in 4 different ways. You have the nominal. I took French when I was in middle school and high school and college, so that's 6 years of French. First time I go to France, sit down in a restaurant, try to order. Waiter says, "Monsieur, monsieur, s'il vous plaît," en anglais, which means, "Mister, please," in English. And I think I was being nice the way I just said it. The tone and condescension was, yeah, it was on a level where it was like, all right, what time does this guy get off? And what exit will he be using?
No differentiate Americans.
Yeah, but I was going to be waiting for him. So it didn't happen. And also, I don't know what the inside of a French jail looks like. I don't know if that's necessarily where I want it to be. So just took a breath, or 30, and ordered. Anyway, I do remember that was written on the top of every worksheet that I had to complete. That's where I had to write my name. So consists of names, labels, categories. Right? So this corresponds with qualitative data. Right? So if you have something that's broken up by gender, age group, whatever, all the examples I mentioned before, that would be considered nominal data. Right? In terms of a graph, so this is qualitative. A pie chart is a really nice way of representing that. A bar chart would be fine too, but they're not as fun to look at as a pie chart. I like pie charts; they look nice, and I think people understand pie charts a little bit better. Just cognitively. You look at a bar chart. You're looking for labels. You're looking for counts and things like that. There's just something about the fractional nature of a pie chart that seems to resonate with people more. When you see a pie chart and you see that one category has like 3/4 of the pie, and then the other 5 categories are making up the remaining quarter of the pie, that really kind of drives the point home even more than a bar chart would. So you could do a bar chart, which is kind of like a histogram, just not connected. It's all still categorical, but graphically I think the best bet is a pie chart. And why do I bring up pie chart? Because if you're doing a project and you're working with nominal data, so something that's categorical, Excel and Google Sheets will do a pie chart very nicely for you. Okay, so that's actually one of the easier charts to create. Ordinal level can be arranged in some order, but the differences between data values either cannot be determined or are meaningless. All right, so the ord part of it, order, okay. You can see that, but the annoying part about this is all the remaining definitions have the word order in it. So in some order, I almost highlighted the wrong thing. In some order, in some order. All right, so no help there. The key component is the differences between data values are either can't be determined or are meaningless. So I'll get to examples of what that looks like in a minute. Interval, the differences are meaningful because there's no way for 0 to be in the set. Ratio, 0 can be in the set. So if you know what the definition is of interval, the interval level, the only difference between that and the ratio level is that 0 can be in the set. Zero can be. It's possible for it to be in the set. It doesn't have to be, but it can be. So you collect your data, 0 never showed up, but it is possible technically that it could. Like, for example, temperatures throughout the year. It is possible that the temperature never hit 0 degrees Fahrenheit, but it could. It's not impossible. Right? So, very close in terms of definition between ordinal, interval, and ratio. Differences can't be determined or are meaningless. Differences can be determined, but you can't have 0 in the set. Differences can be determined and are meaningful, but 0 can be in the set. All right. So, a couple of examples, few examples, whatever the word is for 4 examples. I don't know. A couple is 2, few is 3. I don't know what 4 is. Several examples. So letter grades. I'll just go with the grading system here. In increasing order. I'm not pessimistic. Nope. That would be pessimistic. Make sure I got them all. This is often the first time some people realize that we don't have minus grades at this school. Yeah. No minuses. Only A's and pluses. Yeah, and then we drop the pluses after a time. So actually, it was only at this moment. We only have pluses for 2 categories. I realized. I've been doing this for a while. I didn't even realize that. So yeah, and we'll get into like what the weights are in a minute, because that'll be important to kind of prove a point. But yeah, so you're like, oh, I didn't get an A. Maybe I'll get an A minus. No, you didn't get an A. You're getting a B plus. But also, I personally don't like the minus system, only because the GPAs are, I think, not overly consistent with the letter itself. Like, for example, a B plus sounds like a good grade, but in the minus system, a B plus is a 3.3. Like that doesn't sound like the GPA that a B plus should have. B plus sounds like a good grade, but only a 3.3. That sounds good. Here it's 3.5. You know, A minus 3.7. That doesn't sound too bad. All right. Let's see. A C minus of 1.7. Oof. That doesn't sound very C minus-ish. You know, that's not, like, you figure if you're going to be, like, if you're going to have the letter, you should at least be in the range that the letter corresponds to. C's, you're thinking 2s, right? So maybe, like, a C minus should be a 2, and then a C should be like a 2.3, and a C plus like a 2.6. I don't know. But it's very, I think, severe when you're in the minus system. Here, I think it's kind of nicer. Because you get the 3.5 to 3, the 2.5 to 2, then the 1 and the 0. But, you know, and even still there's flaws to this, because you got to think, like, you got a range of 10 points here, a range of 5, 5, 5, a range of 5, a range of 10, and then a range of, like, 60. Like, 60 ways, really, to get a G. Oh, sorry, an F. Anyway, we have to classify this as nominal, ordinal, interval, or ratio. Well, let's just go down the list. Nominal would be consisting of names, labels, or categories only, cannot assign numerical values. Well, that's not true. Because if that were the case, nobody would care about their letter grade. My C and your A would mean the exact same thing. They're just categories. Who cares? So it can't be nominal. Ordinal can be arranged in some order. Well, that's definitely true, because I just did that. But the differences between data values are either cannot be determined or are meaningless. All right, so this is where it gets a little dicey, because the way it's written these have no numerical value. If I were to say something like, what is A minus C? Without giving you any context, just the letter A minus the letter C. If you don't know what A is or what C is, then you can't answer this question, which would make this ordinal. Now, if I tell you F is equal to 0, D is equal to 1, C is equal to 2, C plus is equal to 2.5, B is equal to 3, B plus is equal to 3.5, and A is equal to 4, then A minus C would be equal to 2. All right, so then what you'd have to ask yourself is, okay, so I am able to find the difference between two data values. All right, so let's read the definition again. Can be arranged in some order, check. But the differences between data values either cannot be determined, well, I just determined them, so that doesn't apply, or are meaningless. All right, so let's think about this for a second. A minus C equals 2. All right. But 2 and C are the same thing. So that would be saying that A minus C equals C. So you just finished high school. This is your first college course. You're almost through it. At the end of the semester, you'll have access to your transcript. I only bring up high school students because it kind of goes to what I'm speaking about. Parents still care about your grades, right? So holiday time comes around, parents are like, oh, how'd you do? You say, did all right. Like, well, what's all right? You get any A's? No, but I got 2 C's. And 2 C's equal an A. So they're right here, right? Because A minus C equals C, which would mean that if I took C and added to it another C, I would get an A. Depending on what kind of parent we're dealing with here, that could be one of these, or it could be a stern talking to. But bottom line is, it's not going over well, because the difference, even though it could be determined, is not very meaningful. So it's still ordinal. Okay? What's that? Ah, they do. They do. They sure do. And I think about that every time I call, like, Optimum or WestMed or whatever, and I get stuck on the phone with some schmo who doesn't know what they're doing, or just, I mean, maybe they do know what they're doing in some capacity, they just don't know the answer to my question. Well, whatever. Anyway, so, I mean, I was just returning a call to my doctor. I was like, well, do you know the doctor's name? I was like, yeah. Do you know who called you? I don't know, but I would imagine it's the nurse of the doctor, because it wasn't the doctor himself. Do you know her name? Like, no, I just told you that. Well, so we can't connect you unless we know the person's name. Well, here's the thing. They didn't leave a name, and I need to call back. So what you need to do is call the doctor's office and say, somebody call Ted Can. Raise your hand if you called Ted Can. Something along those lines, right? So that individual, I believe the qualification for that job was to get a degree of some kind. I don't know what that degree was in.
Yeah, it definitely sounds like West.
Oh yeah, I mean I've had to tell doctors, I'm like, listen, I can't go to you anymore. What's the matter? Well, I can't get in touch with you. I can't make an appointment with you because I can't get past your staff. Well, I'll deal with that. Okay, good. Enjoy that. I'm finding somebody else, because you're not that good of a doctor to require me to go and deal with this nonsense. I can find somebody else that's as at least as good as you, that has staff that is competent. So yeah. Anyway, but I think that's a function of my personality too. I get a little antsy when it comes to that. But anyway, yeah. So there's like, I got a degree, yay, or I actually am like qualified and I care and I want to do well, rather than, you know what? I was going in for spinal injection, and you know what they said to me as I was there? They're like, another one. Man, they overscheduled us. I'm like, hey, so I'm sitting right here. I'm the one that was overscheduled, I guess, but like, I'm about to have a needle in my spine. So can you do me a favor? If you're gonna piss and moan about this, can you go somewhere else and do it? Because I'm kind of freaking out about the whole needle in my spine part. You know, so there is an intelligence component that comes into this also. Yeah, two C's is not equal in A.
Sorry, I'm going back.
What's the answer?
Ordinal, if this. Ordinal, if that. If you can think of anything. Basically, the if part is telling me that there are conditions that allow me to determine that something is ordinal in one, you know, based on one set of premises. You know, I could say, maybe I could come up with some other, I don't know, scenario that will allow it to be interval or ratio. I can't think of anything, but if you were able to, so like on a test, if you were able to think of something, some set of conditions that allows it to be something other than ordinal, that would be accepted. All right, and we'll get to some cases in a few minutes where that'll happen. But in this case, I looked at it two different ways and I came up with ordinal both times. You'd only have to come up with one way.
So basically, we look at that question, and all the school writing wasn't in there. Really just an answer.
Yeah.
Not all you can think.
It would still be ordinal, but for a different reason. So I came up with ordinal here,
Okay.
and this gave it a little bit more context, but I still kept it at ordinal because the difference didn't have any useful meaning.
Because A minus C equals question mark, that's why it's ordinal.
That is, at least before I started writing the blue stuff, yes. Because A minus, I don't know what A is, I don't know what C is.
So it's meaningless.
So not able to be determined.
Not
Then I told you what the weights were for all these things. I got a difference. Right, exactly. I was able to get a difference, but that difference was not meaningful. That's the key thing. Now, you may look at it and say, hey, passing is passing. So, summer rules versus regular semester rules, right? So you're at a 4-year school, and you come here to take a class over the summer. Hey, your C is just as good as my A, because once you transfer those credits, the grade doesn't go with you most of the time. So it's just the credits and the fact that you passed. So in that case, you might look at it and say, oh well, C, A, doesn't matter what it is, they're all equal in my mind. So in that case, you might say interval, you might say ratio. You can come up with a lot of possibilities. The moral here is everything's right as long as you have a reasonable justification. Okay. Gender, I think, is obvious, though, because we're talking about male, female. I don't know all of the different possibilities now, but they tell me that there's one called non-binary. Yeah, so I'll say non-binary. And then I'll go ... to account for whatever's out there. Yeah, I don't even know, like, whatever.
Proper term of intersex?
Intersex is one.
I believe I'm not wrong.
No, that is the right term, yeah.
Professor wasn't us.
My understanding is it's a person that does not identify with either, or is it one that identifies with both? I don't.
Again, I'm not sure.
Yeah.
Non-binary is someone who doesn't go by either, and then there's gender queer, which is like you switch between.
Oh, you alternate back and forth. Oh, okay.
Like, Like something to be like guy, something to be like a girl. Like that.
So
I know
male, female, and then
know this stuff.
just
That's
everything else. And I don't want to say everything else in a derogatory way. It's just things I don't necessarily understand because I'm not there.
Well, we stopped recording a long time ago.
It's weird.
No, we're still going.
I don't question it because like if you don't have heard anyone.
Anyway, nominal. This one's easy because I don't know what m minus f would be. I mean, you might say 0 if you're going for equality, but I mean the letter m minus the letter f. There's no numerical value assigned to it, so I can't go anything other than to say that these are different categories. Right? So that generally is the easy one where you've broken up into different groups. The groups, those group names cannot be identified by some meaningful numerical value. Nominal it is. Weight in carats of diamonds. I only learned this little notation. This was a typo, not a typo, but it was a suggestion from a previous course because I did not know that there were 2 different types of carats. I mean, these kind of carats, because there's also the eating kind. But the carat with a C is a measurement used for gemstones, and a carat with a K is for proportion of pure gold. I have no idea. Fun fact of the day. Not going to be tested on it, obviously, but it's nice to know. So, weight in carats of diamonds. Well, I mean, it's not nominal. It's a weight. I mean, the fact that the word weight is there throws it into quantitative, specifically continuous data, right? So we know that we're living outside of the world of nominal. So it's a question of, all right, well, if I subtract any 2 values, would the result be meaningful? Yeah, probably, right? I would think. So I don't know what like a good number of carats are for diamonds. I know I had to at one point because I had to pay a lot of money for that. But I forget. But I do know that there is a relationship, and if I have, 2 carats, I don't know if that's a good number, and 1 carat, if I subtract the 2, there's a difference of a carat. Like one is 1 carat more than the other. What does that look like? Well, show me what a 1 carat diamond looks like, and that's the difference between the 2. So merge 2 1 carat diamonds together somehow chemically, and there you go. You have your 2 carat diamond. All right. So that's telling me that the differences between the 2 are meaningful. So I'm automatically jumping to the interval ratio because I know that if I have a 3 carat diamond, that's going to be bigger than a 1 carat diamond.
It doesn't mean it's better though.
Doesn't mean it's better because then you get it to clarity and color clarity and size, color clarity. I forget. Anyway, the big question would be 0. Can 0 be in the set? 0 cannot be in the set. So we're going to say that this is on the interval level. All right. Why can 0 not be in the set? There'd be no diamond, yeah. Yeah, no weight, no diamond. I did have a, well, he was being a wise ass at the time, but he made a good point. He was saying, well, in order to have weight, you need to have gravity. Because he was taking physics at the time. But he didn't say it like that. He was like, well. And I'm like, okay, so you're looking for attention. Okay, good. But he made a good point. If there's no gravity, then you can't have weight. So technically, it is possible to have 0. So his point was that if there's a diamond floating out in a weightless environment, like out in space somewhere, like an infinity stone, I guess, I don't know, then it could go into the ratio level. So I was like, all right, fine. You know, but he made a good point.
What about if you find out that the diamond is fake?
That's another point. So we'd have to vet the characteristics of the diamond. It'd have to be legitimate. So like on a test, it would have to be like it is a legitimate diamond. It has been verified to be real. Which category would it fall? And it's on Earth. And gravity did not suddenly disappear on Earth. You know, so it's like every word problem has become a legal document. Body temperatures. So not nominal, because a temperature requires a device to measure it. Ordinal, no, because differences would be meaningful. It's going to be a ratio level. 0 can be in the set. Possibilities, the scale. Are we looking at Fahrenheit, Celsius, Kelvin? Well, if it were Kelvin, then it wouldn't be ratio, because Kelvin is absolute zero, complete absence of heat. I don't see how that could be the case. But body temperature, well, this is where, I mean, we have some pretty significant gray area. We're talking about human. We're talking about living. Body in a meat locker. Yeah, I would imagine it could be 0 degrees. So, and you know, I left this one purposely vague because body of what? Body of water. Oh, probably not, because then it wouldn't be water anymore. I think on any of those scales, right? Because 0 is freezing for Celsius, it's 32 degrees below freezing for Fahrenheit, and it's like no life exists for Kelvin. So, but yeah, I mean, a case, because again, the idea is not 0, and this was the question before. 0, not 0 must be in the set. 0 can be in the set. If you can make a case at all that 0 can be in the set, then it's the ratio level, right? And it can be in the set. It just depends, all right? So your core body temperature would have to be 0, in which case you're probably not alive. But I watch a lot of sci-fi, so every time an attempt to resurrect the Alien franchise comes out, they pretty much start with somebody coming out of cryogenic freeze. So they open the tube, they defrost the person, and then they immediately get attacked and infested by aliens and die at the end. So, or survive to get killed off in the beginning of the next movie immediately.
It can be 98.0.
It would have to be 0 itself. 14.